Hey everybody, so in this video we are going to talk about some measurement conversions. So unfortunately in the United States we use a system called the Customary system, and many other parts of the world they use something called the metric system. So a lot of times we have to convert between different kinds of measurements for a variety of reasons. So today I'm going to kind of show you how we can use the funds situation, the funds method, I guess I should say, to set up proportions so we can solve some unit conversions. So I have 4 examples written here on the page. Essentially, I have given one specific measurement, and then I have put what we are going to convert it into. So if you want to take a moment to pause the video and get all 4 examples copied down, making sure you leave a couple of lines of space in between each example, and then we will go ahead and get started. Okay, so you'll notice at the top of the page, I put kind of a point that you need to use the reference sheet. So there is a STAAR reference sheet that will be posted on your mastery checks, that will be given to you on all your tests and quizzes for you to use to reference the different conversion rates. And I think we might be able to get it printed so you guys can keep it in your level up binders as well if you want. But essentially all of the conversion rates that I tell you guys, I'm getting from this reference sheet. So just make a note, you can always use the reference sheet to get the conversion rates. I would refrain going from Google to get the conversion rates because sometimes they're more specific. They go out to like more decimal places than the reference sheet, and that's extra work. So if you don't want to do that extra work, just make sure you're using the conversion rates on the reference sheets that we give you. So the first problem we're going to do is convert 5.2 miles into feet. So using the funds method, what we're going to do is we're going to set up 2 equivalent fractions. And then I am going to just distinguish what my units are. I have miles and I have feet. It doesn't matter what I put as my numerator or what I put as my denominator. I just need to make sure I stay consistent for both. I think what I'm going to do is I'm just going to put miles as the numerator and then feet as the denominator. And now I'm going to plug in the numbers. So I am trying to figure out 5.2 miles is equal to a certain amount of feet. So the amount of feet is X. I don't know what this value is. Let me zoom in on this particular. Here we go. It's a little easier for you to see. The conversion rate is 1 mile is 5,280 feet. So 1 mile is 5,280 feet. This is the conversion rate that is on the reference sheet. So now that I have set up my units, plugged in my numbers, now I am going to solve. So I'm going to look across to see how am I getting from numerator to numerator, denominator to denominator using that cross rows method. And I know I have to divide 5.2 by 5.2 in order to figure out in order to get 1. So that means that something divided by 5.2 is equal to 5,280 feet. So I'm going to do the opposite. I'm going to multiply those 2 numbers to solve. Another way you could think about this is if I use the cross multiplication method. Essentially, what I am doing is 5,280 times 5.2 is equal to 1 times X, which is just X. So if I did this multiplication, 5,280 times 5.2 is equal to 27,456. 27,456 is equal to X. So it's 27,456 feet. 5.2 miles is 27,456 feet. So I'm going to write that in the final blank as well, 456. Okay, so now let's look at another example. This one we're using the customary units of cups and pints, so measurement kind of when we do baking. So we're trying to put 10 cups into pints. So again, I'm going to use the funds method. I'm going to set up 2 equivalent fractions. My units are cups and pints. I'm going to do the same thing kind of as before, and I'm going to put cups, the first unit, as the top, and pints as the bottom. I'm going to use C and P to represent cups and pints. Sometimes with unit conversions, it's nice to kind of put those as part of the proportion that you set up. But don't confuse them for variables because we don't want to confuse them when we do our multiplication later as a variable. So I have 10 cups is equal to X amount of pints. We're trying to figure that piece out. And the unit conversion that is given on the reference sheet is that 2 cups is equal to 1 pint. 2 cups is equal to 1 pint. So what I'm going to do now is I'm going to solve. I've set up my fractions, plugged in my units, plugged in my numbers, and now I'm going to solve. If I use the crossroads method, looking across, I notice that to get from 10 to 2, I am dividing by 5. So I have to figure out what divided by 5 is equal to 1. Well, anything divided by itself is 1. So that means X is equal to 5. So there are 5 pints and 10 cups. There are 5 pints and 10 cups. I could have used the cross multiplication method. 2x is equal to 10, divided 10 by 2, and have also gotten 5. So these are just 2 examples of unit conversions. Let's look at 2 that have to do with the metric system. So again, these unit rates are also going to be located on your reference sheet. So if you haven't written down these 2 examples, go ahead and take a moment. But basically, we're going to convert centimeters to meters, and then we're going to convert kilometers to meters. So in one instance, we're going from a smaller unit to a bigger unit. And the second instance, we're going from a bigger unit to a smaller unit. So that kind of helps us determine the reasonableness of our answer. So if I am converting 250 centimeters into meters, if I set up my 2 equivalent fractions, I'm going to put centimeters as my numerator, meters as my denominator. Again, it doesn't matter. I could have done either one. The unit conversion that they give me is that 100 centimeters is equal to 1 meter. So there are 100 centimeters in 1 meter. And I am trying to figure out how many meters is 250 centimeters. So in this case, I put the unit rate from the reference sheet first, but I could have done it either way. And so now I'm going to think about how am I getting from numerator to numerator, denominator to denominator to figure out what X is equal to. So I can use the crossroads method, or I can use cross multiplication. Either way I solve, I should get the same answer. If I look from 100 to 250, if I use this crossroads method, I actually have to multiply 100 times 2.5 to get 250. So if I multiply the bottom times 2.5, that is going to get me the value of X. So 1 times 2.5 is going to equal X. So X is going to equal 2.5 meters. 250 centimeters is 2.5 or 2.5 meters. And again, if I use the cross multiplication method, I would do 250 times 1 is equal to 100x, divide 250 by 100, and also get 2.5. Okay, so let's look at the last example. And again, all we're doing is setting up funds and then solving for the missing piece. So I have 1,877 kilometers is equivalent to how many meters? So I am going to do, in this case, I'm going to do meters to kilometers. You could do kilometers to meters. It's up to you. I'm just going to do it this way. If I put my units within the proportion, this can kind of help me place the numbers. So on the reference sheet, it tells you that 1 kilometer is 1,000 meters. So 1 kilometer is 1,000 meters. And we are given 1,877 kilometers, and we are trying to figure out how many meters is that. So again, when I'm looking using the crossroads or cross multiplication method, I am trying to figure out how am I getting from numerator to numerator, denominator to denominator, or if I did cross multiplication, X times 1 is equal to 1,000 times 1,877. Either way, I should get the same answer. To get from 1 to 1,877, I simply have to multiply it by 1,877. So if I multiply the same thing to the top to keep it all proportional, 1,000 times 1,877 is going to equal X, the number of meters. So when I do this multiplication, it is equivalent to 1,877,000. So there's 1,877,000 meters in 1,877 kilometers. So when we're working in the metric system, it's actually not quite that complicated mathematically, because the metric system is all on the unit base of 10. So like 10, 100,000, 10,000, etc. So it makes the multiplication a lot easier, which is why most of the country uses this form of measurement. It's kind of silly that the US and one or two other countries doesn't, but it is how it is. But you'll notice in all these examples, we set up the funds method to solve to figure out the missing unit rate. So this is another example aside from geometry and aside from just the word problems where you can use, where it's important to use the funds method to set up and solve proportions. So proportions come up a lot in different kinds of math, not only geometry and word problems, but now here in some measurement. So use this information to help you as you work on your mastery check or any assignments later on. And I will see you guys later.